Hi. Okay. Okay, I won't try to scare you again. Hi, this is Mr. Moreno. This is for past 6. It's Earth's surface, chapter, whoops, not 1, chapter 2.2. And this is about minerals. Actually, this whole chapter is about minerals. So this is how to identify what a mineral is. And actually, this is not just how to identify minerals. You can identify many things by these properties. So what does that mean? That means that if you have a mineral, how do you know what that mineral is? You can say, oh, I can just look at it. But a lot of minerals look the same. For example, a real diamond and a fake diamond, if you're not trained, they look almost exactly the same. So there are a few tests you can do, and most of these were pretty straightforward. For example, the streak test is when they have a white board made out of, I think it was ceramic, and they slash the stone on there and see what color it makes. That is the streak. Another test was to see the luster. That means, does it look like a metal or does it not look like a metal? And the example they gave was pyrite. Pyrite looks like a metal, and it actually looks like gold. And a lot of people are fooled into thinking that it is gold, and that's why we call it fool's gold. But the difficult one was when it said cleavage and fracture on page 53. Write it here, page 53. Because it talked about something you probably don't know anything about, and that is bonds. And what is bonds? If you remember chapter 2 introduction, which you should have seen that video, it talked about what matter, what everything in the universe is made out of. Protons, electrons, and neutrons. Now, I told you that almost everything, if you zoom it in, it looks like a ball, like this. So an atom, we draw a little circle to show that that is an atom. But how does one atom connect to another atom? Well, the way they connect is by things called bonds. And that is actually, it is the sharing of electrons. So, if you remember, I'm going to draw this real quick and then I'm going to erase it. If I have hydrogen, hydrogen is plus, is electrical, right? And an electron is minus, right? So when it mixes with another hydrogen, when it wants to share, they want to share this electron. Everybody's happy when they share. Now they both have 2 electrons. So now they're happy. They're filled. You don't want to know, you don't need to know why they want to have 2 electrons. You just need to know that that's what this line means in the book on page 53. It means they're sharing electrons. Why is that important? Once they start sharing electrons, once they have bonds, they don't want to break that bond. Bonds are very strong. And in fact, on page 53 on the top, it talks about carbon bonds in graphite. And it shows you a picture kind of like this. And sometimes they can even have 2 bonds, but here I'll just erase this bond so we'll make it simple. This has bonds, so it doesn't want to break. But this is just one layer, just one flat piece of material. But real materials are 3D, right? They have this way, and out. So it's actually 3D, like the picture on page 53. But what happens? This is graphite. Graphite, for example, has bonds in 2D, but connecting one layer with another layer, they don't have strong bonds. They have very weak bonds. And this material, even though it's all carbon, it's only carbon. This material, we call it graphite. And what is graphite? Well, you've seen this before, all carbon. Graphite is what is found in your pencil, the lead in your pencil. That's graphite. That's why it's so easy to break. It has very weak bonds. And do you think if these were strong bonds, the material would be different? Would it be a different material? Yes, it would be actually. If you look at here, I replaced these weak bonds as the same material, but I made them strong bonds now. They're strong, that means they're sharing those electrons that I drew in all directions. If it has strong bonds in all directions, it is now diamond. So if you think about it, the thing inside your pencil, the elements, the atoms inside that pencil lead is the exact same thing that is inside of diamonds. If you actually squeezed it, if you were like Superman and you squeezed a lead pencil very like with a very strong force, with a very strong pressure, it would turn into a diamond, because it is the same thing. It is just carbon. So what you need to know, you don't need to know that there are electrons sharing, but you do need to know that the bonds can make it a different material altogether. This is graphite, this one is diamond, because this has stronger bonds. Now, the second thing, hold on, before I move on, I forgot to mention the important thing. So you had two words, cleavage and fracture. Cleavage, you can think of it like this weak bond. Right here it's very weak, so here it's easy to break. A mineral can break in that direction easily, right? And a fracture is when it can break into pieces that are not very perfect, is irregular pieces. They're not perfect sizes or perfect shapes. That is a fracture. Now, the next one I wanted to talk about was density. This, well, I think it was pretty straightforward, but one thing I wanted to focus on is this symbol. A lot of science words have symbols that are part of the Greek alphabet. And this symbol, rho, this is not, it looks like a letter P, but it's actually, it's like that. It's a Greek letter rho. And whenever you see that in a science book, usually it means density. So what is density? Maybe it was too difficult, but there was a pretty good picture. But I drew another picture up here. Density means if something is denser, if in the same box, this is a box that's 1 meter, 1 meter, 1 meter. So imagine a box. There's 1 meter in every direction. And here's another box, same size. 1 meter, 1 meter, 1 meter, every direction. The length is 1 meter, the width is 1 meter, and the height is 1 meter. Now, if I fill box number 1 with air, inside there's only air, and I fill box number 2 with water, which one will be heavier? Think about it. Okay, if you chose water, that is correct. Water is heavier in the same area than air. And what does that mean? That means it is more dense. So if you want to do a test to see which thing is more dense, think about two boxes that are the same size. If I put one material in one box and another material in another box, which one would be heavier? And in the book, they have two balls. But imagine I have, like a baseball and a tennis ball. Which one would be heavier? The baseball is heavier, so that means whatever the baseball is made out of is more dense. So that's all. Bye.